Switch mode power supplies are highly specialized, and there are many technical terms related to such devices. Thus, many customers contact our company to ask about such terms. This seminar will provide an overview of common inquiries about power supply type names and technical terms. We'll look at causal power supply type names first, and then explain the technical terms. Firstly, let's talk about the rules for creating standard type names. Our power supply type names include information on rated input and output. For example, for an AC/DC power supply, the series is PCA, the output power is 300 watt, and the output voltage is 12 volts. For DC/DC power supplies, the series is MGS, output power is 10 watt, input voltage is 24 volts, and output voltage is 12 volts. To meet the diverse needs of our customers, we offer options that add specific features to our standard power supplies. An option code is assigned to each feature, and the option can be specified by appending a hyphen and this code to the standard model name. Let's use the LHA100F model, a bare board power supply, as an example. Appending the SN option code indicates that the product includes a chassis cover. Please be careful when ordering, as options cannot be added after the product is shipped. Next, let's look at the meaning of the power supply term, efficiency. A power supply cannot transfer all the energy on the input side to the output side. Active power input and power output are different due to power being lost during voltage conversion. The ratio of output power to active power input can be calculated as efficiency using this formula. When selecting a power supply, it is important to modify this formula and calculate the active input power value using the output power value and efficiency value of the property data to be used. When using a power supply, it is not used at 100% load factor, but rather using derating. Since the efficiency value differs depending on the load current value, which is the load factor, it is necessary to check the efficiency at the load current value actually used. Let's discuss it using an example of combining AC/DC and DC/DC power supplies. If you want to run a 10 watt load, take derating into account and use a 15 watt DC/DC power supply. Since the load factor is 67%, the input power is 12.5 watt when calculated using the 80% efficiency value of the property data. Therefore, a product with a rated power of 12.5 watt or higher should be selected for the AC/DC power supply in the earlier example. A 30 watt power supply is selected as part of our power supply lineup. Now, let's talk about ripples and ripple noise. Checking the output voltage waveform of the power supply with an oscilloscope shows that the voltage is fluctuating. This output voltage variation can be divided into three main categories. One is a low-frequency ripple, which is a component synchronized with the AC input frequency and fluctuates at 100 Hz or 120 Hz. Two is a ripple. It is a component synchronized with the switching frequency of the power supply, which can vary from a few hundred kilohertz to a few megahertz. Three is ripple noise and represents the noise component other than a ripple that is superimposed on the output voltage. High-frequency noise of several megahertz or more generated at output from the internal switching transistors or output rectifier diodes. A note about ripple noise. Ripple noise can affect the load on the customer's equipment. If there is flicker on the screen of display equipment connected to the rear of the power supply, ripple noise from the power supply may be affecting the display. In this case, please consider adding a noise suppression component, such as a EMI/EMC filter, to the power supply output to counteract this noise. I will now explain startup and holding times. The time taken for the output voltage to rise to 90% of the rating after the input voltage is applied is called the startup time, and the time the output voltage remains at 90% of the rating after the input voltage is stopped is called the holding time. A note on startup time. The startup time varies depending on the model, so if your equipment uses multiple power supplies, design the system paying attention to the startup time of each power supply. In general equipment, the control system must start up faster than the drive system. Note that if the startup order is reversed, this may lead to drive system malfunctions in some cases due to differences in startup times. A note on holding time. Holding time depends on the load factor, and the lower the load factor, the longer the holding time, so please check the property data. For some bare board power supplies, we can offer units that can extend holding time. Please take advantage of these products, as they can greatly improve holding time. Next, I will explain inrush current. The inrush current is the crest value of the current flowing on the input side at the moment the input voltage is applied to the power supply. This current charges the input smoothing capacitor inside the power supply. Although the inrush current flows for only a few milliseconds, it is several tens of times greater than the steady-state input current, and there is the risk that the external fuse on the input side of the power supply may blow or trip the breaker. To prevent fuses from blowing and breakers from tripping due to inrush current, please check the Joule integral value of fuses and the breaking properties of breakers in advance. Next, let's discuss the difference between variable voltage range and voltage setting accuracy, which are terms used to indicate the output voltage range. Some power supply series have a built-in variable resistors, and the output voltage can be varied by turning a dial. The output voltage variable range indicates the setting range. Conversely, the voltage setting accuracy refers to the range of output voltage set at the time of shipment. A note on the output voltage variable range. When using a power supply with variable output voltage, pay attention to the power and current ratings. The first approach is to increase the output voltage above the rated voltage. If the output voltage is increased from the rated voltage of 5 volt to 5.5 volt, it cannot exceed the rated power of 100 watt. It should be used within a range not exceeding 100 watt, that is, with an output current of 18.1 ampere or less. Note that the usable output current will be less than the rating. The next approach is to decrease the output voltage below the rated voltage. If the output voltage is decreased to 4.5 volt, the output current will be 22.2 ampere when calculated to meet the rated power of 100 watt as in the case of when the output voltage is increased. However, it cannot be used under these conditions because the rated current, 20 ampere, is exceeded. The power supply's rated current cannot be exceeded because the overcurrent protection circuit activates when the rated current is exceeded. Also note that if the output voltage is decreased below the rated voltage, the rated power of 100 watt cannot be used. Finally, let's look at remote control. Remote control refers to the ability to turn the power supply output on and off. Remote control logic varies by model. There are two types: one that turns on when voltage is applied, and one that turns off when voltage is applied. It is important to check the logic of the product to be used in advance in the instruction manual. This concludes the seminar on common inquiries about power supply type names and technical terms. Thank you for watching.